This video is done to explain the exponential smoothing method for forecasting. First, let's confirm that this data is an appropriate data to use to predict using the exponential smoothing method. Block the data and insert a scatter plot with lines. As you can see, the data goes up and down in an unpredictable way. And keep in mind that these are per week values. Since the data shows this characteristic, then a smoothing method is appropriate. You can use moving average 3, moving average 2, moving average 4, whatever is the best method. And usually in the exercises, they specifically ask you to do one method or two methods or three. And in this case, I'm going to do only the exponential smoothing case. So let me create a new column, and I'm going to label it exponential smoothing, and I'm going to put when alpha is equal to, let's say, 0.4. Alpha, remember, is a value that is pre-specified in this method, and it is set as a value between 0 and 1, and the formula is shown in the slides and also in the textbook. In Excel, it's relatively easy to make the calculations by clicking first data, then data analysis, and then select exponential smoothing. Click OK. I've done it before, so I already had calculated the values or entered the values before, but I can re-enter them again. For example, input range, click on the arrow here and select the input range, which are the values of the variable. Then your damping factor is 1 minus alpha. Not alpha, but 1 minus alpha. It's called damping factor in Excel. So enter 0.6. And the output range, here you just click on the box. Now pretend that this is empty, as it is originally, or in the beginning. So you just click here, either on the red arrow, or just clear directly here, C3, which is the top of the values there. Click OK, and you get all the predicted values using exponential smoothing method for alpha equals 0.4. And if you notice, for example, for the second case or the second row, you have the value of 17, which is the same as the actual value of the previous period. On the third row, the predicted value is 0.4 times B4, which is the actual value on the previous period, plus 0.6 times C4, which is the predicted value of the previous period. That is the formula shown in your textbook in the slides. Right? I don't know what I did. Let me fix it. Alright. And all these values are just copied one row below. So the formula is just moving down with one cell at a time. And my MSC, I can calculate it here. The MSC is the average of the arrow squares. Okay. Actually, I need to put it right here. And the arrow squares is the square of the difference between the actual values and the predicted values. Just calculate the difference between the first actual value and predicted values. In this case, it'll be on row number 2, and it'll be the difference between B4 and C4. Oh, squared. Sorry. Okay, and then you just copy this to all the next values, the following values, and you get all the arrow squares. And your MSC is the average of these values, the average of D4 through D14. That's your MSC. Why calculate the MSC? Well, typically that is the calculation that is needed to compare one method versus another method. You can compare this method to an MA3, moving average 3, or a moving average 4, or a weighted moving average. And in each case you calculate the MSC, and the one that has the lowest MSC, that is the best forecasting method.